Hi there, ladies and gentlemen. It's Mr. Pouts, section 6.4 here, and this section is all about the properties of rhombuses, rectangles, and squares. So, our two goals that you should have written down for this section are: I can define and classify different types of parallelograms. We will do more than just rhombuses and squares. Um, or we're going to eventually talk about more than just rhombuses and squares. And then I can utilize properties of diagonals of rhombuses and kites. So we are talking about some diagonals of kites. So a couple of special types of parallelograms first of all. Actually, I made a mistake. I meant to put rhombuses and rectangles on here, not kites. We're going to get to the kites next time. Alright, so I knew something was wrong. First one, a rhombus. Again, these are all going to be parallelograms, just special types of parallelograms. For instance, this first one, a rhombus, is a parallelogram with 4 congruent sides. So any parallelogram that has 4 congruent sides would be a rhombus. Alright, a rectangle is a parallelogram with 4 right angles. So it doesn't matter what the side lengths are. They could be congruent, but they just have to have 4 right angles. A square has to have both. A square is a parallelogram with 4 congruent sides and 4 right angles. So it's a combination of the two. So, what does this look like in a diagram? Well, I believe this diagram is in your notes. What does this diagram show? Well, it shows the connection between the three rhombuses, rectangles, and squares. There are rhombuses that are rhombuses all to themselves. They're not squares, they're not rectangles, but there are also rhombuses that could be squares. There are also rectangles that could be squares. There's it could be a rectangle, rhombus, and or squares. You notice here are both rectangles and rhombuses. Okay, but rectangles and rhombuses, there could be separate ones, and we're going to see a bunch of different ones as we go on. So, is a square a rectangle? Yes. Yes, it is. Is a rectangle a square? Not always, but sometimes. That's tricky because I know they overlap, but squares are always part of the rectangle circle, but rectangles are not always part of the square because there's this section out here that would be not be a square. Is a rhombus a rectangle? And this would also be sometimes, and those sometimes would be when it's a square. All right. All right, let's go on. Let's do some things. We have 3 theorems. I don't think these are written in your. Actually, I think they might be in your notes. This is how they look in the book if you want a picture with them. First one is theorem 613. If a parallelogram is a rhombus, so it's a rhombus, it has 4 congruent sides, then its diagonals are perpendicular. No matter what rhombus it is. Could be a square, because a square is a rhombus. But if it's a rhombus, it has diagonals that are perpendicular. So we have our picture there to the right. Theorem 614 says if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So, if we look at, let's describe what the picture, rhombus A, B, C, D. It's parallelogram, that's a rhombus because they're congruent. We have the diagonals. We know that they're all bisected. So uh, each diagonal bisects the angles that it goes through. So 1 is congruent to 2. 3 is congruent to 4, 5 is congruent to 6, and 7 is congruent to 8. That's for rhombuses, so it can be squares or rhombuses. And then theorem 615 finally says if a parallelogram is a rectangle, then its diagonals are congruent. So with rectangles, not necessarily any rhombus, unless it's a square, but any rectangle has congruent diagonals. So AC is congruent to BD in this case. So let's use those theorems. Let's put those into practice here. We'll do a few of these problems on this page. Um, we're in the first section because it's determining whether it's a rhombus, rectangle, or square, and explain. Now there could be some of each, but we want the most precise uh, classification of it based on what we're given. So number one, we're given. It looks like they're all labeled and all the sides are congruent. That's all we're labeled with. So based on our definitions, all four sides are congruent. That'd be a rhombus. If we look at number two, all four sides are congruent, so it's a rhombus. But it also has four right angles, and if we have both, then it's classified as a square. So four right angles and four congruent sides would be a square. I know they all look like they're one or the other, but number three definitely looks like a rectangle. It's given that only opposite sides are congruent, so it's a parallelogram, and they're all right angles, so this is just a rectangle. And this last one. This last one, we're given one set of parallel sides, one set of opposite congruent sides, and one right angle. Now, based off of these, um, well, based off of these parallel lines, we also know that this is a right angle right here. So that would be two right angles. And since these lines are parallel, if those two add up to 90 degrees, the other two have to be perpendicular as well. Um, because of a theorem we talked about when we have two parallel lines and transversal. If they're congruent, they have to be they have to be the same distance away, so they're congruent. So they'd be in the same location. They could not be in a separate angle. And so here we have four right angles. We have one set of parallel sides, or one set of congruent sides. We can label this as a rectangle. It is not a square. So we only have one set of congruent sides. So it is going to be a rectangle here. Next section, determine the measure of the numbered angles in each figure. Well, if we look at it, it's a rectangle. For number 5, we need to figure out measure of angle 1, 2, 3, and 4. The measure of angle 1, we know that 1 and 30 have to add up to this right angle of 90 degrees. So that would have to leave that to be 60 degrees. Now the measure of angle 2, same thing. 1 is 60 degrees, so they have to add up to 90, so that one has to be 30 degrees. Measure of angle 3, I'm going to look at this triangle, this upper right triangle. We're also going to look at the fact that we have a rectangle means that the diagonals are congruent and they would bisect each other as well because it's a parallelogram. So this would be congruent to this, and if it's an isosceles triangle, that would make that an isosceles triangle. So these two angles in here have to be congruent. So 3 would have to be equal to 60 degrees. And then the same thing would go for the top one. The measuring of 4 would have to be equal to 30 degrees. I want you to do number 6 on your own. This is a square, so think about, I know maybe it doesn't quite look like a square, but think about what we know about the angle measures of squares and what the diagonals do to the angles of squares. Alright, going on, we have a rectangle QRST. Find the value of x and the length of each diagonal. So we have rectangle QRST, we'll say. QRST. If QS, here's a diagonal, is QS, RT, we have those two diagonals. You have those two diagonals. We know the diagonals of rectangles are congruent. That was in theorem 6, where is that? 615. So we can set those two equal to each other to solve for x. Then we can plug back in. So we know that x equals 6x minus 10. If we subtract 6x from both sides, We have negative 5x equals negative 10. Divide both sides by negative 5. X will equal 2. When you plug that back in, we get QS equal to 2. And RT equal to 6 times 2 is 12 minus T, that is 10 is 2, so they are congruent. And number 8 I'd like you to do on your own, given those two. Alright, I have 4 more statements that we're going to answer together. It says determine whether each statement is true or false. If false, rewrite the sentence to make it true. If true, list any other quadrilaterals for which the sentence would be true. So it's multi-stepped here. Number 3 says rhombuses have 4 congruent sides. That is true. That's the definition of a rhombus. But we also know that squares also have 4 congruent sides. Number 14, rectangles have 4 congruent angles. That is true. They're all 90 degrees. Squares also have 4 congruent angles. Interesting. Number 15, the diagonals of a rectangle bisect the opposite angles. We're going to say false, unless we change it to diagonals of a square. A square is a rectangle, but not all rectangles would fit this description. And then number 16, the diagonals of a rhombus are always congruent. So the diagonals of a rhombus are always congruent. I don't think we have that anywhere, that diagonals of a rhombus are always congruent. Unless that rhombus is a square, because a square is a rectangle. And rectangles are always congruent. The diagonals are always congruent. Alright, so that's what we're going to end with. I'd like you to skip to the closing question and try solving this paragraph proof. So it says rectangle DVEO with diagonals DE and OV. That's what we're given. We're trying to prove that triangle OVE is congruent to triangle DEV. So use what you know about parallelograms, what you know about rectangles, and what you know about diagonals of these things, also about triangles, to try to solve that proof. Alright, until next time, we'll see ya.